It's the battering ram bot 2000. And can you turn up the volume?
It doesn't have external speakers, so it might just...
You're back in top.
Alright. Redo. Here we go.
The battering ram bot 2000 is a fierce warrior robot with a huge platform on the front that can be used as a throw mechanism or a battering ram. If I'd had more time, I would have added sleeper now one. The idea behind this robot is to rush into battle, overwhelm the enemy with weapons, and defend through sheer size. To control this robot, push the program on, press the orange button while calling out "Charge!" to calibrate the sound sensor. Use the touch sensors to steer and make a very loud noise of any sort to activate the battering ram. My favorite is yelling commands at the top of my lungs. Smiley face, smiley face, smiley face, smiley face. Unfortunately, pictures are not currently available. To build the battering ram bot 2000, I started with the drive cradle, added the wheels, and hooked up the drift. Then I added the battering ram, a delicate balance of pieces and weights. I also made a ramp and cannon for the cannon ceremony. You'll see what that is after the presentation. Time to begin the demonstration. Hope you like the slideshow.
Thanks, everyone.
The cannon ceremony is sort of an ad for the robot.
If it needs that blue balls, I have those.
I don't need balls. I'll be playing whack-a-mole with this in a minute. And this is the cannon. This looks like a perfect place to practice. That's my aim. Bang, bang. Uh-oh. I'm out of here. Not even a cannon can match the fighting power of the battering ram. Not even a robotic cannon can match the fighting power of the battering ram bot 2000. Now it's time for the demo. Oh, in the form of some sort of skit. That's on. How much must I pay to ride? Maybe sure, like 100 points.
So it's a ride?
Well, it can be.
Oh, it can be.
Right down the helmet. Now I'm going to make a whack-a-mole horse.
It's okay if you can't get them all to stand up. You can just show us at least a couple of them.
And today, it's Ranger and let's go! Let's go!
Oh, it should be wide and single on the wheel.
And
Wide and split on the wheel.
The battering ram doesn't work really well.
That's pretty cool.
Well, can you explain what the controls do?
So, these are supposed to turn the robot up. This is supposed to activate the battering ram when you yell into it.
Alright. Well, it looks cool. Is that it, Evelyn?
That's it.
Alright, thanks.
Hey, get a model like this one to actually work and add the sleep balance. It'll be leaving a trail of victories in its path.
Oops, sorry, let me come back.
The idea behind it. The idea behind Help 2013 is to help people who need to pick up things. Since I programmed this robot, it is automatic, so that the robot can come to you automatically. I hope this robot can really help people who can't pick things up.
Wait.
Right, so this is my robot, and this is the lever, and then this is the two motors to pick up the lever. Okay, so how it's built. The way I built the Help 2013 is first with the basic base. The base consists of two motors and the NXT base. The base can only move forward and backwards. The second thing I added to it was two sound sensors. These sound sensors are there so that the robot can come to you automatically if you stomp your foot. I also added a lever to pick things up. This is very important if you want the Help 2013 to pick things up. And the last thing I added to the robot was an ultrasonic sensor. This sensor was here so that the robot won't bump into anything. So the Help 2013 consists of 3 motors, 2 sound sensors, and 1 ultrasonic sensor. So that's motor, sound, and that. The programming part of it and feature improvements. The programming part of this robot was mostly just trying to get it right. You try until it's right. Also, a future improvement would be to make this robot with 2 NXT bricks instead of 1. On the right side is the programming I used. So in the program NXT, I put blocks in to make it do that. So that's it.
All right.
First, it'll turn it in a circle, and then when you stop it, you've got it. Okay, well, that's the picture. Put it in there. And then it'll come. You will keep doing it. Alright.
Very good.
So this is my robot, and I used 2 motors, 1 NXT brick, 1 gear, and 1 spin gear with an ultrasonic sensor on it. The name of it is my motorcycle. It drives forward, turns left, turns right, and sees things. I could not figure out how to make the front wheel turn, and I could not figure out how to make the front wheel pull the motorcycle forward, so I used the back wheel. I
it did not see something, so it ran into a wall. It kept turning left and just kept turning. The battery died right when I turned on the program for a test, and the keyboard on the computer didn't work. I made it see from farther away. I made it drive forward and turn right. I charged the battery and looked at the battery before I started the program. For the keyboard, I have no idea. I just got here to say it worked. And so this was my project, motorcycle. Kind of need some space to move that.
Okay, yeah. Wait, do you want us to move this chair thing?
Yeah.
Okay, whose robot's on top of that?
That's ours.
You just grab that.
It saw something else, so it turned again. I'm supposed to avoid walls.
It's working.
Okay.
That's so cool. You can show them how you did the gear thing underneath it. That's really cool.
Yeah, I did the spin gear here, which spins when this gear spins when. So that's spinning this gear, which is spinning this gear to make it turn. Programming was a bit difficult, just to make it so that it turned and left and then drive forward and stuff. So this was my robot.
Pulled up because of the tremendous weight, which I found many wheels to keep hold of it for that. And the tail can slash and has disrupted the enemy's cable connections for when the tails hit it. And reputation.
Alright, thanks. So now Evan's going to demonstrate it.
Incoming!
It's killing me. Oh, that's why you don't get the tail so that often. That's why I fixed in the front part. Yep.
Better
Come on, Tom, now. Yeah, it really isn't so much. Kill the tail.
I sort of named my robot Steam. Because Steamboat. Okay. Yeah. How Steam came to be. Well, it was a mistake, really. It was a bulldozer, and it was supposed to push things out, but it wasn't heavy enough so it couldn't push items where it was supposed to. So, my friend had a roll of gears, like this big. So, he had an idea, told me about it, and I used it. And that's how I got the roller, or the yeah. I had an idea of making the bulldozer, but it wasn't working. The motor would not work. The wheel was doing this. So, it flipped over while doing saddle box in front of it, and it drove straight, left to right, as I was going backwards. So, I used it, and then just put everything that I needed on the front, and it worked. Well, as I said earlier, that the idea came from a bulldozer that could not push items or even go straight. And it had a long line of gears, caught a light bulb, and told me, and I lit up. So I rushed to complete it, didn't, I mean, it's still, I had this part, and it was like this, and then I changed it to like that.
Okay.
I learned how to make a program that could control things from this, the NXT block, and two touch sensors. And the purpose of it was to roll over things with this gear roll thing, I don't know what you call it, and to flatten large groups of land. But as you can see, it's quite small, so we couldn't do that. But, so, just to
Is that it?
things.
Alright, you're going to demonstrate it. Thanks.
The middle button works the ultrasonic sensor. Some things are right in front of it. It would move forward, except that the ultrasonic sensor broke earlier today. I have buttons right here. They turn it. This button goes forward, and this goes backward.
Was that it?
Basically all it does is move around.
Oh, it works.
It works,
Thanks.
yeah. Woo! It worked! It worked! The ultrasonic sensor worked.
It did.
He put his hand in front of it, I pressed the middle button and it moved forward.
Oh, okay.
Yeah, it was cool.
Is that what it's supposed to do?
Is that really what it was supposed to do? Yeah. Well, it's not working now.
Sometimes.
Once.
We're going to present, guys.
My name is Rakesh Murugesan, and my robot is named Rob 2.0. One of the features of my robot is the ball hitter. Ball hitter is the main action of Rob. It's programmed so that it only hits red balls, not blue balls. It consists
Sorry about that.
of an ultrasonic sensor, wheels, and motor, a ball hitter, and the light sensor. The blue balls reflect less light than the red ball. The light sensor measures the light reflected to find out the ball color. The ultrasonic sensor measures the ball distance, so it knows when to stop and hit the ball. Driving. The picture is an NXT Mindstone robot hitting a red ball, and the twin motors power the two wheels. There's one. There should be another over there. They can go straight or turn. They're one of the key components in mobility. It makes a right sharp 90-degree turn or spins in place. Two big wheels in the front are the ones that turn and power it. The small ones in the back are for stability, so it doesn't lean back and fall over. The sound sensor, right here. The sound sensor is one of the extra features of Rob. When there's a loud noise or when I clap, it will make a turn or spin in place. We programmed it to detect loud noises and respond to them. The ultrasonic sensor. The ultrasonic sensor finds out when to stop and hit the ball. Without it, it would just push past the ball. The ultrasonic sensor sends out a sound wave, and it calculates the time for it to bounce back, and therefore finding out how far it is. Problems I faced. One problem was how to get the ultrasonic sensor to stop within the area of the ball. Number 2 is how to get the light sensor to correctly find out which ball is blue and which is red. And finally, the third problem is how to turn on the program without the ultrasonic sensor sensing my finger. How I solved the problem. We went to the program,
for the other problem, I think it was... Wait, could you go back?
Yeah.
This was the problem, and this is the answer. We went to the program and redid the maximum distance from the sensor so that it should stop at 9 inches. Number 2 was how to find out what color it was, how to find out the color of the ball. We made the program so that I'll calibrate in the beginning of the program, then I'll know which color it should hit and which to not. And third, so when I do this and turn it on to sense my finger, is I made a button made from a touch sensor and connected it to the NXT brake with a wire so that the button will be the start button instead of the orange button.
Very good.
Like, yeah.
You guys,
That's the bowl stage. This is the calibrating thing. So it didn't hit the blue ball.
try recalibrating it really close like this. You should just recalibrate it as if it was up there, not by hand.
Wait, like here?
Yeah, it's just so it's in the same exact scenario. It's definitely worked. I've seen it, so if it doesn't work.
Hold the ball right up next to it.
Right, and just start it from there. Just see if it works. That's weird. Oh, you added that? Oh, cool.
See if it hits the blue ball.
Yeah, try that. Try switching the balls and see if it hits the blue one. But it probably won't. Yeah.
Make it go forward. I see a light on. Is it sensing the same?
It's shining the light on the ball.
No, he can make it go forward, and when after it makes the sound, he can turn off the program so that he knows the exact space between.
Right, but
Turn off the program right after you hear the sound.
it's not a spacing thing. It's
With an array of weapons and tools of mass destruction.
The hammer. The hammer is one of the most notable features of critical. It's programmed to react to distance, and when at that distance, it swings its hammer up and down until the target is eliminated.
We programmed it with the ultrasonic sensor, allowing it to see, but not to see. You may not understand, but here's an example. A bat knows where it is going, not because of its eyes, but because of its ears. It can sense when an object is near or far. So using an ultrasonic sensor, it can pinpoint the right time and start attacking.
Chainsaws. The chainsaws are one of the most dangerous parts and fast. With an 100 on power and years doubling that. It's something enemy robots should watch out for.
It works in sync with the ultrasonic sensors, but because due to limited programming capabilities, it spins up and down for repeatedly short amounts of time. Before that, a button, a touch sensor, which looks like this, activated and deactivated the chainsaw. It's not on. Controls. Using a touch sensor, we can control which direction, left or right, the critter changes it into. Using a simple mechanic, we got 2 touch sensors and programmed them for turning left and right. Left and right. This is the newest edition, so it may be under technical difficulties. Drive. The drive may be the most odd part of critters, and at least advanced. It's a little shy, so if you want it to move, you should probably cheer and compliment it, and it'll probably move. But the secret behind it is he's not really shy. He reacts to sound using the sound sensor. That's all, and we'll start the demonstration now. Okay.
Wait, did your saw fall down?
I will go.
We don't attack her.
The mad crab.
The mad crab. This one turns it right, and this one turns left. And when he is in front of it, it can sense what he is and will immediately attack him.
No!
Sorry. I think it's specifically
Attack him! Charge!
I see my charges.
So that's our robot.
Lights.
Okay.
PowerPoint action.
Okay. Well, our robot is a go-kart. Made by Jared and Jackson. We came by this design when we saw a video on YouTube about a race car with shifting wheels. We thought this was really cool, so we decided to try and make it a reproduction of what we saw. The purpose of the robot go-kart is to drive around. It was going to be a racing car, but due to its weight, the car is slow. We built the car with 3 motors, 4 wheels, and 8 gears. The turning mechanism is made by a rod that forms rectangles like this. When the motors push the parallel rods in the opposite directions, the wheels on either side turn. We ran into quite a few problems, though. Unfortunately, the car drove slow, and so we had to add 8 gears. We had trouble getting the gears in place, but finally it all fit together. Next, the programming. This was extremely difficult. We had help most of the time. It was big relief when everything started to work the way we wanted it to. We both learned a lot, especially the programming, because neither of us knew anything about programming before this camp. We had to change things like the gears because it was going slow and because it wouldn't fit. We had to change motors because one of the 3 were defective. It also had to find ways to make the car more secure so it wouldn't split. Overall, just a big set of trial and error.
Demonstrate.
Okay. So this goes. The right button makes it go forward. The left button makes it go backward. And then while you're going forward, you can turn with each arrow button. So like that. It was going a lot slower turning. So that's how the pretty simple turning the rectangle works. So yeah, that's the different card.
Very good.
8,000. My robot was meant to be a race car. It moves forward pretty quickly on its own as soon as it hears sound. Buttons to turn it like a device. At first I had a gear system to make it faster, but it didn't work. I tried lots of things to fix it, but nothing worked. Eventually I just had to take out the gear system. And this is the programming I used.
All right.
If this comes to you, please grab it and hit the button because I have no way to stop it.
Come here.
Charge!
Oh, it's not on yet.
Hey. Alright, this is our robot. I got the colors on it. The name of my robot is Alphabot 2.0, aka the Board Breaker. You will see why it's called that in a little bit. The engineer name is Robotics Dalton. Yes, that is me. I designed this robot from scratch, so there are some errors. The idea behind this robot is to use touch sensors to control the robot. I came up with this idea because I like to have more robots that are controlled by me. The purpose of this robot is to break the boards that I put out. The boards break away easily, though, because we don't want to break any Lego bricks. I built this robot from scratch. Some challenges were tipping, the arms coming off, and the wires getting in the way. Easy solutions were an extra wheel, more support, and moving the wires aside. What I learned during this was to make sure to use plenty of stabilization for the arms and motors. This would prevent tipping and breaking. If I had more time, I would have built a turning mechanism and a lighter claw arm, allowing it to move more easily. Pictures are not available, however, you will see the robot in action soon. Enjoy! Again, the wires get in the way, so it's very annoying, because sometimes this giant robotic arm actually, knocks off the wheels. It is very weird. So, put this on wheels so it just follows that and doesn't, hold it up. Sometimes this takes a little bit of calibration because it doesn't always hit the boards on the first try. Yeah, it tips a lot because the front wheel is like a giant moving thing, but it did, however, break the wheels. Let me reset them. Sometimes, if I can get it just right, the catapult will also break the boards. Oops. A little bit. Finally, we will be using the forward and backward system. The target is way out here. Oh. Then it also goes backwards. So. Yeah, sometimes the backward feature doesn't work. Anyway.
Oh, nice.
My project.
Robot is the robotic baseball machine, and the engineer is me. How it was built. The robotic baseball machine was built with 3 motors, one for fielding, one for hitting, and one for throwing. For fielding, when an ultrasonic sensor senses the ball coming, a scoop will come down and field it. For hitting, when an ultrasonic sensor senses the ball coming, it swings a Lego piece at it and hits it. For throwing, I press a touch sensor and it catapults the ball. I faced some problems, including having to reprogram because somehow programming was lost, and having each thing not work, but I managed to work through it. The idea behind the design is pretty simple. Well, I just came up with the idea because I wanted to make a pitcher to pitch to. We did a baseball batter, a robotic baseball batter earlier in this week, and I wanted to make a pitcher to pitch to it, so I started with the catapult, and it slowly evolved into the robotic baseball machine. The purpose of it is just to field, hit, and throw like a baseball player. And when making my robot, I learned how to program them to do certain things and how to use the motors to make other things work how you want them to. And really only the future improvement I would make, since it's already pretty fragile and about to fall apart. So I would make it on wheels so it can move around. And then while I'm doing some of this stuff, everything's working at once, so like these things are going to be moving if I'm doing this stuff. So it can throw the ball like that with the catapult arm, and the touch sensor is right here, and you put the ball in the catapult arm, and you press the touch sensor and it will throw the ball. Yeah, that's the bat is getting a little bit feisty. And then for the bat, you can.
Oh, I think it's because it's getting.
Yeah, I know it's so if you roll a ball for it, that was a bad roll. And hit it.
Cool.
Like that, because the ultrasonic sensor senses the ball coming in. It senses the ball coming in. Oh, come on.
What do you think it's that?
That's a problem that I face too. The bat is coming through and it's not coming all the way back, and then it's sensing itself. So you can roll it and it hits it. And then for the fielding part, over here on the side, this is the suit, call it the glove, you want it to. And when I roll the ball to it, the scoop should come down. I need to get it back up. It should come down. Oh, come on. Keep missing.
Oh, man.
If I could roll it straight, it would do it. Oh, come on.
I just turned. There's like an entirely even robot.
Oh, nice. Very good job. That's a cool robot.
We can't show.
It uses Lego bricks, which is what it's made out of. It uses 4 touch sensors. The only remote that you use. I use them for controlling it. It uses 4 motors. It uses 2 for driving and 2 for the call. And it also uses a Lego NFC board. And it's basically the computer that my programmer for them. it scoops up and picks up random things. You can control it with the remote. The 4 buttons, they control forward, to the right, to the left, and flip. And it's more of a remote control car than actually a functioning cleaning robot. If I had time, I would make it also able to basically clean up without using a remote. I'd make the claw longer to pick up more things. I'd try to make my robot lighter because in my demonstration it'll probably flip itself because the claw's so heavy. And I try to reinforce the motors a little bit more. Sometimes the motors pop off. I wanted to make a dump truck because I stole all my Lego parts and I tried to make something to clean it up. It's ironic because my robot doesn't actually clean up anything. At first, I wanted to build the robot to lift other robots up after I got the idea, but then I decided it'd be a better dump truck because the motors aren't strong enough to actually lift anything up other than just random parts. I built my robot after I made the basic frame out of a bumper car robot that we learned how to do. I removed all of the parts of the bumper car that weren't part of the frame. Like, there was a part in front that stopped when we pushed on it, it made it turn. Then I made the dump truck from the bumper car frame. One problem that I encountered is that the claw was way too heavy. So I tried to make it better by the straps to my claw, and it makes it lighter. I learned how to properly program my robot. I had to make 3 different, I should have posted a picture on here, but I had to make it branch off into 3 different commands. I learned how to use the gears to increase the speed of the torque, and I didn't actually put gears on it because the gears weren't strong enough. They made out of plastic and they would just click out of place. And I also learned how to balance the weight and not make my robot too unstable. But I didn't really apply it to my robot because it doesn't move. This is turning, so this right button is turn right, second one's turn left, this one's flipping my claw, and the last one is driving. So it's basically like a remote control car.
You missed.
Yeah, I missed.
It could be a backwards
No,
catapult.
it missed.
Oh yeah, it could be a backwards catapult. May I help? Yeah.
No,
Oh yeah, that's another problem.
Here, may I help like we did earlier? Here.
What's something in this background?
Oh, I missed. Here. You both missed.
Here.
You gave me it, people.
Oh.
Too soon.
Did it too early. Boom, boom, boom.
Yeah.
Idea behind it. I got the idea for this robot. Blind people can't cross the road without help, and the robot person had purpose to help blind people navigate around things. How it was built. I ran into many challenges. One is that I had 4 numbers but only 3 number ports. So I have to make 2 numbers share. Future improvement. I would make it so that my robot does not stutter. Pictures.
Cool.
Oh, yeah, we did a new
Do you need more space? Here, guys, back up a little bit, give me more space. Yeah, you just. Oh, that tire is off. That's why it was skipping.
help my people.
Like it's off the rim. Is that better? Hmm.
which is fun. But one of them
So the touch sensor makes it go backwards?
Yeah.
Cool. And then what does the ultrasonic sensor do?
It makes it turn.
Turn, okay, cool. Is that it?
Yeah.
Alright, thanks, Art. You guys are going?
Our milestone project, just by both of us. The idea behind the design was we thought of a helicopter and decided to put the helicopter blades onto the robot. Purpose of the robot. The purpose of this robot is to move around freely, avoiding objects. How it was built. We had two motors with wheels, bricks, another motor with blades. The challenges we faced were wheels not turning in the same direction, and the helicopter blades not turning at limited times. Things we learned. We learned how to loop something infinitely and how to use sensors. Future improvement. Some things we could improve on is to build onto it and demolish other robots.
Okay. What's you doing that?
Okay.
What's supposed to be happening?
Okay, maybe.
Don't you demolish my robot.
It is a demolisher.
Is that it? Yeah. Alright, cool. Thanks, guys.
That's not actually it. That's close I could get to a picture of it. And I was engineering it pretty much, and my friend John, who is my partner, was the programmer. The idea of the design and the purpose of the bot. Me and my partner had an idea of a giant claw, I guess. I don't know how it sort of got into our mind, but we both liked it, so we did it. And the purpose of the bot was to pick up the ball and put it into the basket, which is behind it. Building of the bot. At first, it was hard to build the bot because the claw kept on breaking every time it bent over to pick up the ball. We also had to make one side heavier because the claw was a little bit big. Improvements in the future, I think we would have made a stronger base for the robot and a claw, so it wouldn't just break every time you tried to pick up the ball.
Did I skip something?
Also, we would have made the claw arm able to turn around to pick up the ball.
Okay.
And so the button here sort of activates the claw to grab it. And yeah.
That's really cool.
Sorry, I'm going to try that again. And so, yeah.
then you don't get the prize. You don't get the stuffed animal.
All right, very good.